Okay, so hello dear students. Today we will discuss introduction about centrifugal pump and subject is applied fluid mechanics as per the G2 syllabus. It comes under module number 4 turbo machinery and our topic is introduction about centrifugal pump. Now first of all, before we start our discussion, first of all we have to understand what is the meaning of centrifugal pump. So you can see here I have written here the hydraulic energy is in the form of pressure energy, and if the mechanical energy is converted into pressure energy by means of centrifugal force acting on the fluid, the hydraulic machine is called centrifugal pump. So it is a very simple definition of centrifugal pump, and a centrifugal pump is classified as rotodynamic pump also. If we talk about the purpose of centrifugal pump, it is generally used to increase the pressure energy. Secondly, to impart the kinetic energy. Thirdly, to lift and circulate. And fourth one, to exhaust or extract the liquids. So these are nothing but the purpose of the centrifugal pump. Now if we talk about the principle of the centrifugal pump, on which principle centrifugal pump generally working, so you can see here the basic principle on which a centrifugal pump works is that when a certain mass of liquid is made to rotate by an external force, it is thrown away from the central axis of rotation and a centrifugal head is impressed, which enables the liquid to rise to a higher level. So particularly in this particular principle, your centrifugal pump is generally working. Now we will talk about the component of centrifugal pump. So you can see here there are 7 components. First one is impeller, second one is casing, okay, third one is suction pipe, fourth one is delivery pipe, fifth one is delivery valve, sixth one is float valve, and seventh one is strainer. So we will discuss each and every component here. So first of all, I will show you the diagram of the centrifugal pump. Okay. So you can see here, this is your strainer portion. Can you see here? Okay, I will annotate here. Okay. So this is your strainer portion, and above the strainer here one foot wall is provided. Both the assembly is inside the sump. Here sump is provided. Okay. So under the sump, foot wall and strainer is there. Then it is connected with suction pipe. You can see here. And suction pipe is connected with the impeller. Here outside portion is called casing, and inside the casing impeller is there. This is your center line of the pump. And then it is after that connected with the delivery pipe. Here delivery valve is there, and delivery pipe is connected to overhead tank. Okay, and this is your discharge level. This is height HD. You can see here HD. It is the delivery head from center line of the pump to the discharge level, and this HS from the sump water level to the center line of the pump. HS means your static head. Static head. This is your suction head. HS is your suction head. Suction head, and this is HD your delivery head. Summation of both HS plus HD is known as the static head. Okay. HS is your suction head. So we will discuss each and every component. Okay. So let's move. So first component of the centrifugal pump is impeller. So what is that? It is a wheel or a rotor with a number of blades or vanes fitted on it, and it is fixed on the shaft. You can see I have already shown you the figure. I will again show you. So this is your impeller. Okay. These are your blades. The function of the impeller is to provide the centrifugal head and to provide the high pressure. Okay, the function of the impeller is to provide the centrifugal head and to provide the high pressure. And there are 3 types of impeller: closed impeller, semi-open impeller, and open impeller. You can see here I have shown the figure. Okay, so this is your radial type of impeller. Okay, second one is your axial flow type of impeller, and third one is your mixed flow type of impeller. Okay, and here in the below of this particular figure, open, semi open and closed impeller is given to you. So open impeller, you can see this type of figure is there. Okay, in semi open, plate is on only one side, plate is provided only on one side, where here in the enclosed type, means closed type impeller, both the side plate are provided. Okay, so this is an example of open, semi open and closed impeller or enclosed impeller. Now second component of centrifugal pump is casing. The impeller is enclosed in a watertight casing having a delivery pipe in one of its sides. Okay, the casing for a centrifugal pump is so designed that the kinetic energy of water is converted into pressure energy before the water leaves the casing. So you can see again, I will show you same figure. So this is your impeller and surrounding this impeller casing is provided. So your impeller is inside the casing. Okay, this is your casing. You can see this is your casing. An impeller is inside the casing. Now there are three types of casing: volute casing, which is also called spiral casing, vortex casing and volute casing with guide blade. So what is volute casing? Such a casing provide a gradual increase in the area of flow, which decreases the velocity of water with corresponding increase in the pressure. So you can see this type of figure is there. Okay, which provide the gradual increase of the area, but as pressure will increase, velocity of water will decrease in the type of casing. Okay, so you can see this is your volute casing. Then second one is vortex casing. It is an improved type of volute casing, means it is a improved version in which the spiral casing is combined with a circular chamber, and in a vortex casing the eddies are reduced to a considerable extent and efficiency is increased. Okay, eddies means circular movement of water which are generally generated, that we call eddies, that are reduced to considerable extent and efficiency is increased. So you can see here, this is your vortex casing. Okay, so it is combined with the circular chamber. Then volute casing with guide blade. Volute casing with guide blade. In this type of casing, there are guide blades surrounding the impeller, and these guide blades are arranged at such an angle that the water enters without shock and forms a passage of increasing area through which the water passes and reaches the delivery pipe. Okay, so you can see here, these are the guide vanes. Okay, this is your impeller, and these are the guide vanes, and water will then further will goes to this way to the delivery pipe. Okay, so casing is provided with casing with guide blade. You can see here casing with guide blade. Okay, so there are three types: volute casing, vortex casing and volute casing with guide blade. Now third component of centrifugal pump is suction pipe. So this is a pipe connecting the pump and inlet of this pump. Okay, this is a pipe connecting the pump and inlet of the pump, and a non-returning valve is provided at the lower end of this pipe. And what is the function of this non-returning valve? This valve does not allow the water to drain out of the pipe when the pump is not running. Okay, so I have already shown you the figure of suction pipe. So you can see this is your suction pipe. Okay, this is your suction pipe. This is your delivery pipe. This is your delivery valve. This is your strainer. This is your foot valve. Okay. Then delivery pipe. This is a pipe connecting the pump outlet. Okay. Now here it is a pipe connecting the pump outlet to the delivery tank that I have already shown you. A delivery valve is provided near the outlet of the pump in order to regulate the flow into the delivery pipe. As I already shown you that figure, delivery valve is provided and it is provided near the outlet of the pump, and the function of the delivery valve is very simple, just to regulate the flow into the delivery pipe. Okay. And that pipe, delivery pipe, is connecting at the which place? At the pump outlet. Okay, the outlet of the pump to the delivery tank. Then delivery valve, we already discussed. Delivery valve is provided near the outlet of the pump to regulate the flow into the delivery pipe. And sixth one is foot valve and strainer. A foot valve is provided with strainer, is connected at the bottom of the suction pipe. Okay, this figure I have already shown you. It is connected at the bottom of the suction pipe, just for which purpose? To avoid the entry of the foreign matter. To avoid the entry of the foreign matter. Okay, so we have discussed various components of the centrifugal pump. Okay, starting from impeller, casing. There are types of the casing, types of the impellers. Okay, then suction pipe, delivery valve, foot valve, strainers. So these all are nothing but component of the centrifugal pump. Now we will move further and discuss working of centrifugal pump. Very important. How your centrifugal pump is generally working. So you can see I have written here. Same principle, the basic principle on which centrifugal pump works is that when a certain mass of liquid is made to rotate by an external force, it is thrown away from the central axis of the rotation, and a centrifugal head is impressed, which enables the liquid to rise to a higher level. That we already discussed in the starting slide. Okay. Now here the first step in the operation of a centrifugal pump is called priming. Okay. Before we start the pump, okay, we have to do the priming. So what is the meaning of that? So you can see here, we note that the pressure developed by the impeller of centrifugal pump is proportional to density of the fluid in the impeller. Okay, this sentence you have to remember. The pressure developed by the impeller of the centrifugal pump is proportional to density of the fluid in the impeller. If the impeller is running in air, what will happen? It will produce a negligible pressure, which might not suck the water from its source through the suction pipe, because pressure which is generated is very negligible, and because of that pressure it is not able to suck the water from its source. Okay, hence in order to operate the pump, it is necessary that pump should be filled with the water, and this process of filling the suction pipe and the impeller with water before starting the pump is called priming. So this is the, you can say, ultimately meaning of the priming. Okay, that's why before we start our pump, we have to fill the suction pipe and impeller, and that process is known as the priming. Okay, understood? Now we will go further regarding the procedure, how it works. So during priming, what we are doing, delivery valve is kept close. You know the location of the position of the delivery valve. Okay, so during priming, what we do, delivery valve is kept close, and after priming is done, prime mover means electric motor is started. When we start our prime mover, at the time also delivery valve is kept closed. Okay, during priming we kept close our delivery valve, and after priming also, when we start our motor, delivery valve is still kept close. Now what will happen? Energy given to the impeller by external source. Now we will give some energy to the impeller. So energy given to impeller by external source is transferred to working fluid, which increases the kinetic and pressure energy of the fluid. Okay, once you provide the energy to that particular working fluid, okay, energy given to impeller by external source is transferred to working fluid, which increases kinetic pressure energy. What will happen? The rotation of the impeller causes the strong suction in the eye of the pump. I will show you I have already shown you the eye of the pump. Okay, so rotation of the impeller causes strong suction in the eye of the pump, and after the impeller attains its normal speed, because you already provided the energy to the impeller, and then it is transferred to working fluid. So once after some time your impeller will attain some normal speed. So after the impeller attains normal speed, what will happen? The delivery valve is open. After that we are opening that particular delivery valve, and what will happen? Liquid is allowed to flow through the impeller vents, and it attains higher velocity of liquid, and then it enters into delivery pipe and is lifted to required height. Okay. Then after that what will happen? At that instant, partial vacuum is created at the eye of the pump due to centrifugal action of the impeller on the liquid. Okay, this is the central end of the pump, you can see, and this is eye of the impeller. This is your eye of the impeller. You can see my cursor. So at that instance, partial vacuum is created at eye of the pump due to centrifugal action of the impeller on the liquid, and this helps liquid to rush through the suction pipe towards the impeller eye, just to take place of the liquid which has left the impeller vents. And when the pump is to be stopped, the delivery valve should be first closed to stop the backflow of the liquid. If you don't close, what will happen? Backflow will occur, and that might be damage your pump also. So when pump is to be stopped, the delivery valve should be first closed to the, just to stop the backflow of the liquid. So this is a general procedure, or you can say working principle of the centrifugal pump. Okay, so I think you understand. I have tried my level best to explain this procedure. So before we start our centrifugal pump, our first step is to do the priming. Okay, and I already told you what is the meaning of priming and how we are doing the priming. We have to just fill the suction pipe and impeller with the water. That process is called the priming. During priming, we have to keep our delivery valve closed, and after priming, when it is completed and we start our motor, at a time also we have to keep our delivery valve closed. Okay, then we have to provide some energy to impeller by external source, and then it is transferred to working fluid. Because of that, kinetic and pressure energy is generated. Okay, rotation of the impeller also cause strong suction at the eye of the pump. Okay, means it attains some speed. Your impeller will attain some speed, and because of that, what will happen? Whatever flow is there, it will pass through the impeller vents, and it also attains some velocity and try to enter in delivery pipe. And at that time, you have to open our delivery pipe also. But when this type of process is happening, partial vacuum is created because of the centrifugal action of the impeller on the liquid, which helps liquid to rush through the suction pipe. In which direction? Toward the suction pipe and towards the impeller eye, just to take up the place of liquid which is already left from the impeller vents. Okay, so this is working principle of centrifugal pump. I have one video also. I will show you that video. So we have 2 or 3 minute video. Okay, so I think you understand very well. I already told you the procedure about the working of centrifugal pump, and I've already shown you the video also. So I think by seeing the video, you can easily understand how your centrifugal pump is generally working. Okay, now we will discuss our next subtopic. Okay, one more thing that in this particular centrifugal pump, you can see here flange is provided. Flange is generally one method just to connect the pipes. Okay, so here suction flange is provided, here delivery flange is provided. It is just connecting the two pipes, and you can see here vacuum gauge is provided just to measure the pressure. Okay, it is one type of pressure gauge which measure the pressure below the, okay, absolute atmospheric pressure, okay, which is lower than the atmospheric pressure. So that is the purpose of vacuum gauge, to measure the pressure. Here also you can say pressure gauge is provided. Okay, now we'll go further. Now classification of a centrifugal pump. So classification, there are so many classification based on type of flow. There are three classification: axial flow pumps, radial flow pumps, mixed flow pumps. We will discuss this all the three. Then classification based on the plate on the side of the impeller, that this we already discussed: closed impeller, okay, semi closed impeller, and open impeller. This we already discussed in the starting of the, when we discuss about the component of the impeller. I have shown you the figure also. So now we will discuss these three: axial flow, radial flow, and mixed flow. So you can see radial flow centrifugal pump. This is the figure. In a radial flow pump, what will happen? The liquid enters at the center of the impeller. Okay, it will enter at the center of the impeller, and it is directed out along the impeller blades in a direction at right angles to the pump shaft. Very important, at right angles to the pump shaft. That called radial flow centrifugal pump. Okay. Now, second one, axial flow centrifugal pump. Okay, so in axial flow pump, the impeller pushes the liquid in a direction parallel to the pump shaft. Previous one is perpendicular, and here it is, your impeller pushes the liquid in a direction parallel to the pump shaft. Okay, axial flow pumps are sometimes called propeller pumps also, because they operate essentially the same as the propeller of a boat. So you can see this is the figure of the axial flow centrifugal pump. Then mixed flow centrifugal pump. Next one. So mixed flow pumps borrow characteristics from both radial flow and axial flow pumps. As liquid flow through the impeller of a mixed flow pump, what will happen? The impeller blade pulls the liquid out away from the pump shaft and to the pump suction at an angle greater than 90 degree. Okay, so this is a typical diagram of the mixed flow centrifugal pump. Okay, it has both the characteristics of radial flow and axial flow. The next classification is based on the head. So low head pump is there if your head is up to 15 meter. medium head pump is there if your head is 15 to 40 meter, and high head pump is there if your head is over 40 meter. Okay. Then next is classification based on the disposition of the shaft. In that, horizontal shaft is there and vertical shaft is there. I will explain this both the thing. Okay. So what is horizontal shaft? These are the pump with the shaft in horizontal plane. Popular due to ease of servicing and maintenance, and it is sometimes overhung or placed between the bearing design. Okay. And second one is vertical shaft. Vertical centrifugal pump have their shaft in the vertical plane. Here in a horizontal plane, here in a vertical plane. They utilize unique shaft and bearing support configuration, which allows the volute to hang in the pump while the bearings are outside the pump. Okay. And it is generally an overhung and of radial split case type of design. So these are the types of centrifugal pump based on the shaft, horizontal shaft and vertical shaft. Then based on the number of impellers in the pump, next classification. So in that again, single stage pump, two stage pump and multi-stage pump. So what is the meaning of single stage pump? Single stage pump means that the pumps have only one impeller and the highest lift is 125 meters. Okay. Then a two-stage pump. A two-stage pump has two suction impellers operating side by side. And this operator must decide if he wants volume or more pressure by selecting a switch on the pump panel. Okay. Then multi-stage pump. Multi-stage pump means the pump have two or more impellers and they can absorb pressure of water in different levels and time so that the water can be go up to a high position. And the lift can be changed by increasing or decreasing the number of stages of pump impeller. Okay, so this is the meaning of single stage, two stage and multi-stage pump. So we have discussed classification of the centrifugal pump. Now our next topic is specific speed of the pump. So specific speed of pump is defined as the speed of an imaginary pump. Very important. The speed of the imaginary pump geometrically similar in every respect to the actual pump and capable of delivering unit discharge against unit head. Okay, so it is an imaginary pump, but it is geometrically similar to actual pump in every respect. Okay, so mathematically we can write this way: ns is equal to n under root q upon hm raised to 3 by 4, where ns is your specific speed in rpm, q is your discharge, and hm is nothing but head per stage. You can see here some value is given. If your pump is radial flow, speed is suppose slow, specific speed is generally lies in the range of 10 to 30. If your pump has speed of medium speed, then specific speed range is lies 30 to 35. If your pump speed is high and radial flow pump is there, then specific speed lies 50 to 80. Then suppose your mixed flow pump is there, specific speed lies 80 to 160, and if your pump is axial flow, specific speed lies 100 to 450. Okay, so this value just you have to remember. Now head of the pump. So there are two types of head: static head and manometric head. Manometric head is also called total head. So what is the meaning of static head? We already discussed in starting of the first two slides. Static head generally denoted by HS. Okay, and what is the meaning of that? The sum of the suction head and delivery head, HS and SD, is known as the static head, and we can write by this way: HS is equal to small hs plus small sd. Okay, then manometric head, which is denoted by hm. The manometric head is defined as the head against which a centrifugal pump has to work. So total head or manometric head is given by this way: hm is equal to capital Hm is equal to small hs plus hd plus small hfs plus small hfd plus vd square by 2g, where hs is your suction head, s for suction head, hd d for delivery head, hfs means friction head loss in suction pipe, and hfd is friction head loss in delivery pipe. And what is vd? Velocity of water in delivery pipe. D for delivery pipe. Okay, so there are two types of head: static head and manometric head. Now we'll discuss one more subtopic, that is pump in series. Okay, pump in series. So you can see the figure. This is your shaft. This is your shaft. And here two impeller. One, this is impeller number 1, you can see, and this is impeller number 2. Both are attached in a series. Okay. This is the suction pipe from which water is enters and then going to this way to the delivery pipe. And this is your guided passage, you can see. Okay. So what is the phenomena? Whenever a higher head or discharge is required, what is the point? Whenever a higher head or discharge is required, multi-stage centrifugal pump is used. We are not using single stage pump, but we are using here multi-stage centrifugal pump because our aim is to get the higher head or discharge. In multi-stage pump, the impeller are arranged in a series and mounted on the same shaft. Okay, I have already shown the figure. Again, you can see the figure, same figure. This is your shaft, and these are your two impeller, 1 and 2. Both are attached in a series. Okay. Now further, the head produced by a centrifugal pump depend on the ream speed of the impeller. On which it depends? Ream speed of the impeller. And to increase the ream speed, either the rotational speed or diameter of the impeller or both must be increased. If you want to increase ream speed of the impeller, what you have to do? Either you increase the rotational speed or you increase the diameter of the impeller, or you increase both. Okay. But increase either of these will increase the stress in impeller material. If you increase only one or or only diameter, so what will happen in case increase either of these will increase the stress in the impeller material, and for this reason it is usually not possible to produce very high head with one impeller only. And this is the reason why we are going for the multi-stage centrifugal pump instead of single stage centrifugal pump. Okay. So what will happen? The outlet of first impeller enters into the second impeller as shown in the figure. You can see here. Okay. Outlet of the first impeller is attached with the inlet of the second impeller. And the liquid coming out of second impeller is passed through the delivery pipe. You can see here again. This is your delivery pipe. So outlet of the second impeller is attached with the delivery pipe. Okay. The water from the suction pipe enters the first impeller at the inlet and is discharged at the outlet with the increased pressure. And at the outlet of second impeller, what will happen? The pressure of the water will be more than the pressure of water at the outlet of the first impeller. Okay. So this is a very simple phenomena you can see here. As I already mentioned earlier, this is the suction pipe, water will go this way, then enter at the inlet of the second impeller, and then water will go the outlet of the second impeller to the delivery pipe. Okay, and here pressure will be more than the outlet of the first impeller. Okay, so here this is the reason. Ultimately, the reason is that if you want to get higher head or more discharge, we have to arrange our pipe in series. Okay, but we have to use multi-stage centrifugal pump. So let N is number of impeller mounted on a same shaft, and HM is head developed by each impeller. Total head developed is nothing but N into HM. And if discharge is Q, we have taken same for each impeller. Okay. Now second case is pump in parallel. Sometimes we put our pump in parallel also. So you can see here both the pumps are here. Both our pumps are kept parallel to each other. This pump number 1, pump number 2. Okay, this is the delivery pipe for pump number 1. This is the delivery pipe for pump number 2. Both are connected with common pipe. Okay, this is your sum portion. Okay. So for obtaining high discharge, 2 or more pumps should be connected in parallel as shown in the figure. I already shown in the figure. Each of the pump lifts the water from a common sump and discharge the water to a common pipe to which the delivery pipe of each pump is connected. Okay, that I already shown you. Again I am showing you. Okay, this is the common sump. Both the pump taking the water from this sump, and that water goes through a delivery pipe. Okay, delivery pipe for pump number 1, delivery pipe for pump number 2. Both are connected with the common pipe. Okay, both are connected with the common pipe. Delivery pipe 2, delivery pipe 1. Each of the pump is working against the same head. So let N is number of identical pumps arranged in the parallel and Q is your discharge from one pump, then total discharge is nothing but N into Q. Okay, so we have discussed when pump is arranged in the series and when pump is arranged in the parallel. So pump in series and pump in parallel. Now next subtopic is characteristics curves of a centrifugal pump. Okay, so what is the meaning of that? A pump is normally designed for a particular value of speed, head and flow rate, which are known as the design condition. Generally, whatever pump we are using, that have some characteristics. Okay, they are designed for some particular condition. Okay, means for speed, head and flow rate. Okay, and that condition we call as a design condition. Means pump is generally designed for design condition. But you know, in actual practice it will not happen. Okay, it is not happening. But in actual practice, the pump may often be required to work at different condition, at different working condition for which it has been designed. And therefore, in order to predict the behavior and performance of a pump under varying condition, under different condition, tests are performed. We are performing the test on a model or prototype of a centrifugal pump. And results are plotted. And whatever results we are getting, we are plotting that results in a graphical form. The curves thus obtained are known as the characteristics curve of the pump. Okay, understood? It's a very simple definition. What is the meaning of characteristics curve? Because our ultimate aim is to predict the behavior of the centrifugal pump, performance of the centrifugal pump. And how we can predict that? By doing testing. We have to take some prototype or model of the centrifugal pump. We have to do some test. We have to collect some results. That result we have to plot in a graphical form. That is nothing but your ultimately called as a characteristic curve. Okay. So you can see here there are three types of characteristics curve: main characteristics curve, operating characteristics curve and constant efficiency curve. So what is main characteristics curve? The main characteristics curve of a centrifugal pump are plotted for variation of power, manometric head and discharge Q with respect to speed. With respect to speed. So you can see the figure. So here I have plot power, head and discharge against this speed, and I am getting these three different main characteristics curve. Okay, here P proportional to NQ by keeping Q and H constant. Here your H is proportional to N square where Q is constant, and here Q is proportional to N by keeping H is constant. So based on this particular characteristic curve, we can judge or we can predict the performance and behavior of this centrifugal pump. Second one is operating characteristic curve. The pump is normally designed for maximum efficiency, you know very well, and that occurs when pump working at the design speed, and that is only possible when it will operate under the design condition or design speed. And in order to get optimum performance of pump, it is necessary to operate the pump at the design speed. Then you will achieve maximum efficiency. Hence, a particular set of main characteristics corresponding to the design speed are called the operating characteristics. And thus, operating characteristics curve are obtained by plotting efficiency, power and head against the discharge, keeping speed and is constant. So you can see here I have plot discharge versus efficiency, power and head graph by keeping the speed constant. So you will get this type of graph. Okay, you can see maximum efficiency I am getting, and then it will be decreased. So this is nothing but your operating characteristic curve. And third one is constant efficiency curve, which is also called as iso efficiency curve or muscle curve. And to get these curves, the H versus Q curves and eta versus Q curves for different speed are used. Here for a given efficiency, there are two values of discharge and two values of head for a given speed. I will show you the figure. You can see. Okay, two value of head for given. Okay, 1 minute. I will show you. So here for a given efficiency, there are two value of discharge and two value of head for a given speed. And if the efficiency is maximum, there is only one value of discharge and one value of head for a given speed. So by adopting same procedure for different speed, we can get number of curves of discharge versus efficiency and discharge versus head. Okay, so this is the figure you can see here. Okay, This is the Q versus head, and this is the discharge versus efficiency. And you are getting the constant efficiency line, you can see. Now next topic, and that is the last one for the today webinar, cavitation. So what is cavitation? Cavitation is a phenomena in which rapid changes of pressure in a liquid lead to the formation of small vapor which fill the cavities in places where the pressure is relatively low. So when subjected to higher pressure, what will happen? This cavity called the bubbles or voids collapse and can generate the shock wave that is strong very close to the bubble, but rapidly weakens as it propagates away from the bubble. Cavitation is a significant cause of the wear in some engineering context. Okay, so wearing effect. So what are the effect of cavitation? Efficiency of the machine is lower down. Damage to the blades due to the pitting effect continuously. And noise and vibration. These are the effect of the cavitation. So our next question is, what are the prevention measures? So these are the prevention measures, that the liquid temperature should be as low as possible to keep the vapor pressure down. Secondly, the velocity in the suction pipe should be as low as practicable. And third one, as far as possible, the sharp bend in the suction pipe should be avoided to reduce loss of head. Okay, so sharp bend we have to avoid. If you don't avoid, then what will happen? Loss of head will be there. Okay, so these are the 3 precautionary measures you have to take to eliminate the cavitation. Okay, so our today webinar is now over. Now I am opening the questioning session. Okay, if you have any query, you can ask the question. Only request is that you just when you ask your question, you just open your microphone, means unmute your microphone, and then when your question is over, you just put your microphone on a mute condition. Okay, so today in my lecture I have tried to cover basic of the centrifugal pump. Initially we have discussed what is the centrifugal pump, definition of centrifugal pump. Okay, then we have discussed what are the purposes of the centrifugal pump. Then we have discussed principle on which your centrifugal pump is generally working. Then we have discussed about the component of the centrifugal pump. We have discussed each and every component with diagram. Then we have discussed what are the working principle of centrifugal pump, on which principle your centrifugal pump is generally working. Okay, and I have shown you the video also. That video is very helpful to you. You will find on YouTube also. I have taken from the YouTube itself. Then we have discussed pump in series and pump in parallel, means when in which condition we have to keep our pump in series condition and in parallel condition. Then we have discussed classification of the centrifugal pump. Then we have discussed different heads. Okay, static head and manometric head in a centrifugal pump. Then we have discussed main characteristics curve. Characteristics curve of the centrifugal pump. In that there are 3 types of characteristics curve, and there are uses. And then specific speed of the centrifugal pump. And finally, we have discussed cavitation, effects of the cavitation, and what are the precaution measures you can take. So within 1 hour, I will try my level best to cover all the subtopics which comes under the centrifugal pumps. So now question session is open. If you have any query, any problem, you can ask me. Otherwise, as well, I told you earlier also, you can you just send me email on my email ID kbpatel 5 times 9 99999 @gmail.com, and one more email ID kbpatel 4 times 9 9999 @gmail.com. You just put your query, okay, and send me an email. I will definitely try to solve your query and give your satisfaction answer. Okay, so still we have some time. If you have any query, you can just ask. And I think this lecture will help to the mechanical student also. Okay, they will also learn in 4th and 6th sem as the semester will proceed. So for both civil as well as mechanical students, this I think this lecture will be very useful. Okay, so just I am opening the session. हेलो हाँ कौन बोल रहे
हेलो
हैं?
सर।
हाँ बोलो रिद्धिका.
रिद्धिका
हाँ बोलो रिद्धिका.
सर, आप पीपीटी व्हाट्सएप ग्रुप में शेयर કરી દો ને.
Yeah, definitely. Don't worry. I have already sent previous PPT also. I was in Google Classroom also. I was sent, and your request is also definitely I will fulfill. I will send you in WhatsApp group also. In our Google Classroom, you just
થેન્ક
see the
યુ.
yeah, definitely. I have already shared previous PPT also. Okay, today is my fourth webinar, and I have shared all the PPTs not only for fourth sem student, sixth sem student, eighth sem student, even second sem mechanical student also. And today PPT I will also share you in Google Classroom as well as and in WhatsApp group also. So don't worry, definitely. Is there any query, any question? Okay, thank you so much. So once again, I'm very thankful to all the people that you attended my webinar so patiently, and I am very thankful to you. Thank you so much. So if you don't have any queries, so just I am ending my today webinar. Thank you so much. Thank you.